Hi, my name is Roan. I'm going to be giving you a short presentation today on my major project for the MPP 405 course. We're going to have a look at the objectives for the project, the considerations for the design. I'll give you a short demonstration and we'll have a look at the findings as well. So the project title was an investigation into experiential learning-based simulators in educational app design. So this title was developed due to a number of factors. Students starting the SAE audio production degree were susceptible to information overload when they first started the course. So this was something that I'd noticed over around 5 years of teaching, and I wanted to make it easier essentially for students to pick up some of the more practical skills that we were trying to teach them. I noted that signal flow was one of the tougher subjects for students, which did actually lead to me choosing this as a simulator that I would make. The other thing that was an influence on this was the fact that the curriculum changed, and it meant that students no longer had to undertake a signal flow exam on a physical piece of equipment or an analog piece of equipment. So that meant that they were actually learning their signal flow from DAWs, which ended up in them picking up some habits which didn't actually translate into the real world, essentially. So I developed a signal flow simulator which they could use and tried to incorporate elements of experiential learning into the simulator. I wanted to make sure that it was actually improving the performance, of course, so I came up with this hypothesis. The use of a simulator application based on experiential learning can improve conceptual understanding for level 4 audio students. So the hypothesis was tested by going to a number of the UK campuses, Liverpool and London, and testing students in a practical signal flow on an analog desk. And I did these tests a week apart. In the interim, one half of the students actually used the signal flow app, and there was a comparison of the scores after that week to test for the effectiveness. So in terms of the whole project objectives, I wanted to design a useful ergonomic tool. I wanted to improve the students' engagement, and I wanted to develop myself professionally. So just going through these. The design of a useful ergonomic tool, first of all. This was making sure that I used the appropriate pedagogy. So in this case, I had aimed to use Kolb's experiential learning model because I thought that it would fit in well with the practical intent of the course. I wanted to incorporate features that the students would find useful, so this involved the use of focus groups and individual user testing, and I wanted to put this out on the most appropriate platform. So questionnaires gave me information about the technology that most students had. So in this case, it ended up being either a laptop or a phone. So due to the prevalence of Macs, I decided to develop this for the Macintosh platform. There were some issues in terms of screen size and the ability to get all the information that I thought was needed for the simulation onto a smaller kind of phone screen. So that might be something which could be developed after this has been handed in, but for just now it was developed just for Mac. In terms of the improvement in engagement, I mainly got my information for this from test scores. So this was the signal flow test that was carried out a week apart, and also from questionnaires and debriefs after students had used the simulator for the week. In terms of professional development, this would be something that I would class as a reflective practice. So I, in reflection, believe that I have developed professionally, and I've entered into an area which I didn't actually have a specialism in before. So in terms of programming and software design and things like that. It wasn't something I'd done before, and it was something I was always interested in, so I used this as a way to essentially enter into that kind of realm. So in terms of the design considerations, I had to create a functional mixing desk simulator containing logic for various solo modes and routing options and things like that. So I needed the simulator to act like a real world desk essentially. So that involved a bit of kind of programming and kind of some deeper thought about the logic of how mixing desks work, and I had to make sure that it would stand up when students were experimenting with ideas, as it is essentially a huge part of Kolb's model to experiment. Speaking of Kolb's model, I had to integrate the experiential learning model, which David Kolb developed. So this involves a number of different stages, but there are aspects of obviously using a realistic simulator. There's needs to be an opportunity for reflection, there needs to be an opportunity for experimentation, things like that. So the other thing that I wanted to bring into the design was the gradual introduction to concepts. So this actually came from the focus groups, and it was a suggestion that we came up with together as to how to present information and make it digestible, essentially. So the way that I did that was I essentially made a level design in the simulator that the student could gradually work through and hopefully grasp the concept before going on to the next level and build on the knowledge that they'd previously picked up. So let's actually have a look at the app now, and I'll give you a quick run through it. Let me just make this presentable. This would be the start page for the student, and they would be taken into the menu after this. So if we just actually work through the first level here, so you can see that it describes the things that they're going to be looking at, and we just click on here. So the information was delivered via these text panels. So instructions would be given here. I tried to make the key words easy to see and easy to remember by obviously putting them in capital letters here. So I wanted to give a description of what the things did. I wanted to then give the student steps to go through and kind of follow along. So in this case, we're giving a description of what these controls do, and actually getting the student to follow these. So what we need to do here is essentially we need to put up the control room level and bring up the master fader. So when we do that, we should actually get some audio. If we go to the next level now, you can see we've introduced more elements of the signal flow. So again, you are going through a repetition of actions here, which should help with the retention of information, and we're introducing new elements here, so we should be able to bring in individual elements now, and mute and things like that. So if I just go back to the main menu here, you would gradually work your way through these different levels, and you can see you actually end up at a free mode. So if we click on this, this offers suggestion in how you could experiment with the mixer essentially, which, as I say, is a key part of Kolb's model, allowing that experimentation and the application of kind of theories that you may have come up with yourself. So if I just close this window here, we can now see the full mixing desk. So hopefully by this stage you will have learned what all of these things do and how they interact. So we can actually do things like add reverb. I'll do that now. Of course, the drums stop. We can do things like create cue mixes, and we've got various types of solo here to check our signal flow as we go. Okay, And if I monitor the cue mix here,
Cue mix.
I'm given an audio cue
Cue mix.
to tell me that this is the cue mix running. So,
Cue mix.
there we go, still going. So yeah, I restricted the frequency response and added the audio cue to that, just to make sure that the student knew that they were listening to the cue mix there. Other aspects, we do have inserts. So again, I bring up the drums. We can compress the drums. We can EQ, very basically. We can use various types of solos. Now, this was one of the areas which I thought was very important to model correctly, as new kind of users to desks and new people on the course can find solo types quite confusing. So it was important to get this right. It did take quite a lot of time to get the logic for this to work properly, but it was worth it because students will hopefully get a better understanding of the 3 types of solo that I'm trying to get across to them. So you can see how the different solos work here. So our in-place solo just mutes all the other tracks here. If I use a PFL solo here, it goes to the solo bus and is not affected by the main fader. I also have AFL solos for the auxiliary masters as well. So essentially this should be a working, albeit very basic desk here that the students can make use of. As I say, it should stand up to experimentation, so it was important that it couldn't essentially be broken and it followed the logic of a real mixing desk. If we just come out of this, we can have a look at a bit more detail concerning the actual design. So this is the software that I used, or one of the softwares that I used for creating the application. This is Unreal, which is a games engine, but I've actually been using a section of it called the UMG editor, which is generally actually used for things like health bars and on-screen displays and things like that. But I've essentially only used this, and this is the interaction that the students have. So yeah, this essentially connects up to a whole load of logic which is based on the level. So this is the blueprint, as they call it in Unreal, for the level, which contains all the logic that we need to use from here. So if I just zoom in, let's zoom into something a little simpler. So fader levels, for example. What we have here is we have an audio component, and what's essentially happening here is that you are telling the graphical interface here to change something within Fmod, which is the other half essentially of this setup. So the Fmod supplies the audio, and the Unreal supplies some of the logic and the graphical interface. We can see some of the blueprints are a little more complicated. So if we make our way over to probably the most complicated blueprint, we have the network for the solo system. So what happens here is there's a whole load of decisions that need to be made based on various states of the desk. If I actually open up and play with the solos, we can maybe have a look at this in a little more detail. Let's just see if I can make this window a little smaller. Okay, might not display quite correctly, but we can actually see the red line showing how the signal flows through the blueprints or the instructions. If I hit solo here, we should see a change. Okay, so it's going through a decision tree and making these changes. If I bring up PFL, again it changes to a different solo mode. If I bring in different solos, you can see how the routing changes through this. So one of the more complicated aspects of the simulator that had to be done there. If we just have a quick look at the other half of this, Fmod. Fmod was supplying all of the audio for the simulator here. So here we have various different aspects of Fmod. Now, in the project, this is described in much more detail, but essentially what's happening here is this is laid out like the signal flow of a mixing desk. So this is the core level of the drums, essentially. Now, that's where the audio resides, which makes sense. We can also see the parameters for this level here. So I can, for example, set this off and switch on the insert, okay, which obviously compresses the drums. So this is where the information from Unreal is passed into Fmod and actually changes various settings and levels and things like that within here. So this would be either done by events on here or by snapshots, which actually affects levels in Fmod. So that's a kind of very quick overview of the design and aspect of the project. So in terms of findings, it was found that the app improved signal flow test scores by a mean of 40.4% compared to non-users after a week of using the app. So this was a kind of a pretty good result. Again, there are aspects which could be carried out on a larger scale over more users. The project itself, I can see going forwards and expanding. So if we were just to stick with the signal flow simulator itself, there's various different aspects I could add in. There could be things like metering, or some of the suggestions from student focus groups and feedback, whether they would like to have different graphics. So one of the things that happens with these students is that they rely too much on one specific graphic. They could have various different graphics that they could choose from, so that when they encounter a new desk which is laid out slightly differently, they're not going to be quite so baffled by it. Other things included the ability to put in their own multi-tracks and things like that, which could all be worked on. Going beyond that, I would like to see this integrated into the curriculum in a flipped classroom kind of idea. So this is again talked about in the project, and I would like to see this integrated into the curriculum in the kind of best way possible, rather than just being a kind of augmentation to the side. I would like to see it actually included quite centrally to the curriculum. So going beyond this, the signal flow kind of aspect, this could be spread out to a number of different applications which could be developed. The students can access these from the virtual learning environment, and these could be used to get information across. And you know, rather than use the lecture as a delivery device, this could be used alongside kind of lectures. You know, some students may find it easier to uptake the information if they're actually doing this stuff and kind of working to the experiential learning model. So that's my presentation. Thanks for listening. Thank you.